In this question we have F2 and F3 are unknown, and we are given also the resultant being 45 kilonewton downwards aligned with the y-axis. So to solve this problem, we need to first of all list the rules of resultant because it involves resultant. So is sum of all forces in x direction is equivalent to the x component of the resultant, and the sum of all forces in y direction is equivalent to the y component of the resultant. So this is what we care about for now, and well, this is equation number 1 and this is equation number 2. So let's take a closer look to this question and see what we can imply from the given information. So it says that R is aligned. So what does that mean? It means that if the R or the resultant is aligned with the Y, it means that we don't have an X component for resultant. What does that mean? It means the Rx is equal to 0. So what does that make the first equation? The first equation now becomes the sum of all forces in x direction was equal to Rx is equal to 0. So the conclusion is the sum of all forces in x direction is equal to 0. So this is the first conclusion for this question, and it is very important to make this conclusion to be able to solve this problem. Now let's move to the second part of the question. So now what does that make for the y? We said in the case of the y, the sum of all forces, I should change the color, sum of all forces in y direction is equal to the y component of the resultant. Now we know from the look of the question here that the resultant itself is lying in the y direction, so it means actually this is equal to R itself. So now again this sum of all forces in y direction is equal to R. That is the second conclusion to be able to start to work on this problem. So as a result, before we start to dig into the numbers and do the calculation, we have to say we'll use these bases to calculate the values of F1, F2 and F3. That is the sum of all forces in the x direction is equal to 0, equation number 1, and the sum of all forces in y direction is equal to R. This is the second equation which will help us to calculate the forces in F2 and F3.